In this video, we are going to discuss number 20 in the Math 1 to 2 Statistics 1 course. It says the weights of the melons produced by Jacob the farmer are normally distributed with mean mu kilograms and standard deviation of 3.55 kilograms. So the variance will be 3.55 squared. It says if 2.68% of the weights measure less than 8.5 kilograms, find the value of the population. So this is a similar question to number 19, but it's just in a worded form where you have to find the value of the mean. Let's analyze it a little carefully. It says the weights of the melons are normally distributed with a mean mu and a standard deviation of 3.55. Now, it's a 2.68%, so that is 0.0268 of the weights measure less than 8.5. 0.0268 is less than 0.5, so this is a tail. This is a tail. And let's see what kind of tail. It's a left tail. So it says 0.0268 of the weights are less than 8.5. Less than meaning you have to shade towards the left. Okay. Below 8.5 kilograms. 8.5. So 8.5 and below that you have 0.0268%. So 8.5 must be on the left side of mu for there to be a left tail. So therefore, mu, the population mean, must be greater than 8.5. And another important note, the z will be a negative number because 8.5 minus a number bigger than it, x minus mu, because z is x minus mu over sigma. So the difference between x and mu will be a negative value. So z is on the left side of 0. Z would have to be a negative number. Now bear in mind, the table, we must go into the table to get the z value. And the table do not give negative z's. So it appears that whatever z we get from the table, we have to attach a negative sign to it. Now to go into the table, we need a chunk, not a tail. We cannot go into this table with a tail. As you can see, this table does not have any value less than 0.5 because as the legend shows, it gives you phi of positive z's, which are big chunks. And be it left tail or right tail, you cannot find that value in the table. So let's see an example in Unit 6 to take a look at the algorithm to do such a question. So this is example 5.5. Let's go lower down. 5.6. That's the right tail. Finding mu when you have a right tail, we can take a look at it if we don't have a left tail. So let's take a look at how this one was done. So first, it says the lengths of metal bolts are normally distributed from mean mu and a standard deviation of 7 centimeters. If 2.5% of the bolts measure more than 68 centimeters, find the value of mu. More than, that means you have a right shade to the right, 0.0268, 0.025, that means you've got a tail. So this is the right tail, as you can see. So here mu is less than 68. All right, so when you standardize 68 minus mu over 7, all right, you are unable to go into the table with that probability value of 0.025, but you can do a 1 minus 0.025 and go into the table with a 0.975, okay, to get that chunk. Remember, it's the z we want, okay? So if the 0.025 here cannot give us the z from that table, it can give it the z from another table, you know. You can go in another table that is calibrated for tails and you can get your z value. Okay, but seeing that we are limited to this table, we are using this table, we do a 1 minus 0.025 and we go into the table 0.975 and it will give us the same z. Okay, bear that in mind. So once you have a value less than 0.5 for your probability value and you want to find a z, just take it out from 1 and go into the table and it will give you the z. So we go into the table 0.975 for this example. And here we have it. Let's go to the table 0.975. Zero point nine seven five. 0.975. Here it is. 1.96. There's a little table there also below that gives some specific values. We can use it also, giving you it facilitates that very same process, finding z's. If you have these values of p, okay, 0.975, you can get your z. 0.9, you can get your z. 0.975, you can get your z. 0.99, you can get your z. So 0.975, here it is again, 1.96. So in certain questions that give these exact values of p, you can go here to get the z for it. Okay, and then what you simply do is, right, equate it to 68 minus mu over z over 7, and then you do your algebra and you solve for mu. As you can see, mu is 54.28, which is less than 68. Here, you did not have to attach a negative sign to the 1.96 because we're in a right tail. Okay, but in this example, in this question number 20, we have a left tail. 0.0268 is a tail less than shade towards the left. That's a left tail. So our z, we must attach a negative sign to the z. But before you can go to the z, you know you have to subtract this from 1. 0.1 minus 0.0268. And if this value, that is what you go into the table with to get your z. Put a negative sign to it and then do the algebra to solve for mu. And you should get a value which is more than 8.5. Because 8.5 is to the left of your mean value. Right, so I hope this helps with the solution for number 20. And you can use the algorithm here in this page 15, example 5.6. The only difference is that you've got to attach a negative sign to your z after you obtain it from the table.